Greetings. I wanted to make a video showing off this project I've been working on. I'm using Bevy, the game engine Bevy. Yeah, so I you can ignore the name SDF world. I was originally going to be trying to mess around a bit with signed distance functions, SDFs, to try to render 3D shapes using SDFs, but that I kind of ended up taking a different direction. So that's why the name really doesn't have any relevance to what this is. What I'm actually using here is the marching cubes algorithm, which is very interesting. I've become kind of captured by this recently. I've been highly interested in this, and this is also my first time using Bevy. I tried out some of the examples a while back, but this is my first real project using Bevy. And this is very simple. I just kind of, I'm not doing anything really complicated yet. I just wanted to see if I could define some 3D meshes, some 3D shapes using the marching cubes algorithm. And so I use this website a lot. Let me see if I can show. Yeah, this looks fine. So essentially what this algorithm is doing, this is actually a nice example here, this image. The 3D space is defined using a scalar field, which is essentially just a collection of numbers. And in my case, I made it even simpler. I'm not even using a collection of numbers to define points in 3D space or to define the value of terrain in a 3D space or the value of a shape. I'm really just using Boolean values for now. So true would be there's terrain in that spot, in that location, and false would be empty space, right? And using this collection of Boolean values, it essentially is, a 3D. You can think of it like a 3D array, or you can think of it as just points on. In my case, it would be the center of each of these invisible cubes. I'm calling each one a cell. So at the center of each cell, I'm defining a true or false value that defines whether or not there is solid terrain there, and it ends up looking a lot like this image, because this is a very you can see it's a very simple shape. It doesn't have a lot of smooth edges or complexity. But once you start using an actual scalar field with actual numerical values, then you can make the shapes look a lot more kind of organic, I guess, or a lot more interesting, more like natural terrain or whatever else you want to render. I mean, an example of that would be down here. You can kind of see this is showing the increasing resolution of the scalar field. So if you want to have a very high resolution, you can get some very smooth looking objects like this. But for a game, for games like games that use this technique, such as Astroneer, or the newest Donkey Kong Bonanza, I believe, is also using some form of this to define the terrain in these games. You really only need something like this, right? I mean, this looks pretty nice for defining terrain. Yeah, and so let me kind of show what I've done so far here. I have this temporary function. Let me move this down a bit. This I'm using to essentially just pass in a point in 3D space, and it just returns true or false. And I added this statement here to define a hill in the 3D space. I just wanted to have basically flat ground with one hill, or really it's more like a cliff. And I can show you here. So the area that I'm currently defining now is small, so that's why it cuts off at certain points. And you can see my hill that I wanted to render obviously has some issues. So let's get closer here. You can see it resembles what I wanted, but what's going on here with these with the edges here? When I first saw this, I was a bit confused because it seems like very close to what I wanted, but it's slightly off, right? You can see each strip, I guess you could say, of this edge. It seems like it's just a little bit off, like the triangles are being defined just slightly off. So it's always kind of tricky when you get an issue like this where it seems like it's almost working right, but just slightly off, right? And I used the code from this website as a reference, and I was very careful when I followed through the entire algorithm, and so I was kind of stumped for a while. But and also, by the way, like I mentioned before, I tried to keep it as simple as possible, which is why there's no lighting yet here. It's very all of this, the entire surface is just one color for now, so that's why it's kind of hard to see where the terrain begins and ends. But you can see this is an issue on all 4 edges. And so let me go ahead and show what the issue was. So basically, where I'm, as I mentioned, I'm only using Boolean values for now, whereas the code in here was already using numerical values to define the scalar field. And so I guess I oversimplified a bit too much. And what I was basically going to do was just use halfway points for each corner of this cell, right? So you can see when you have a surface being defined inside this cell, what it would normally do in this algorithm is it would interpolate between, like, say you want to define this point of this triangle, it would find somewhere nicely in between this corner of the cell and this corner of the cell, and it would try to place it somewhere nicely in between, somewhere where it should fit, and give you a consistent surface that doesn't have any holes in it. But since I'm using a Boolean value, very simple, true or false, I just wanted to have each point correspond to the halfway point of each edge of each cell. So, and that's how you get shapes that look like this, right? It's very simple. Basically just 90-degree angles and 45-degree angles, etc. So, yeah. So what is the issue, and why did I not get what I expected? Really, it was just this this half point function. Really, it's just a number halfway between 2 numbers. I just forgot to put the parentheses here to make the order of operations what it should be. And now if I run this again, you'll see what the terrain looks like now. You can see that now my hill, or my cliff, looks correct, exactly as I expected. And yeah, and you can see there's these kind of 45-degree angles on the edges here, which looks quite nice. I'm really excited to see what it'll look like once I have numerical values defining this scalar field. But yeah, so I decided to use Bevy for this because I'm a big fan of Rust. I think Rust is a very, very nice programming language to use. I've used Unity in the past. I'm not the biggest fan of Unity, to be honest. I think it's good for quick projects and stuff like that, but I wanted to try something new. I'm also interested in Godot, another game engine. I almost used that one, but I wanted to give Bevy a try, and so far my experience has been quite nice. But this is a very simple project. I'm still waiting to see how Bevy really scales once you have a lot of things going on. Once you have a real game project with lots of different components and things like that. I'm sure it gets a lot more complex, a lot more difficult, but I'm interested to see how Bevy is, what the development experience is like once you have a project like that. But yeah, so that's what I've been working on, and that's really about it. I'll post an update once I have a bit more done here. I want to clean up a lot of this code, and yeah, I'll post another update hopefully soon.